So for today, we are going to be talking about what the periodic table square tells us about an element. And we're going to focus in our notes on page 3 on the element boron. So this square on the periodic table, 5b10.81, we're going to go ahead and look on page number 3 of the packet at what that actually tells us. So this is that square, just drawn bigger so that we can actually look at it. And there's a couple of pieces of information that are located in this square. I'm going to just start with the middle. So this is called our atomic symbol. And the atomic symbol is essentially just a shortcut way of writing the name. This is the element boron. We abbreviate that with a capital B. The first letter of an element symbol is always capitalized. So notice it's a capital B, not a lowercase. If there's a second letter, which for boron there isn't, it is always lowercase. And that helps us determine if we have an element or if we have a compound. So for example, if we had CO, if I wrote it as 2 lowercase letters versus 2 uppercase letters, uppercase and a lowercase, versus 2 that are uppercase, that's actually different. If I write capital C, lowercase o, this is the element cobalt. But if I write capital C and capital O, this is telling me that carbon is in a bond with oxygen, and this is called carbon monoxide, which is a colorless, odorless gas that you have detectors for in your house to make sure that it's not gathering because it is a killer. You don't want to be breathing that in. So these are 2 very different substances, and again, the way that we write them with capital letters or lowercase letters differentiates between them. Okay. Our other 2 pieces of the symbol are numbers. The number that is always a whole number, and it's the smaller of the 2 numbers, this is called the atomic number. And the periodic table is in order of atomic number. So you start at the top left of the periodic table, that's number 1, and then as you move from left to right down the periodic table, they're all in order. The atomic number is actually going to tell us one really important piece of information about that element. The atomic number tells us the number of protons that that element has in its nucleus. So I know that boron has 5 protons because its atomic number is 5. The atomic number is actually what tells us what element it is. If I have an element that has 5 protons, it is always boron, no exceptions. That's the only piece of information that allows me to determine what element we're looking at in terms of the numbers. Okay? So the element is determined by the number of protons only, not the number of neutrons, not the number of electrons, not the mass, etc., right, etc. So the only thing that's going to tell me what element we're looking at in terms of the numbers is just the number of protons only. The other number that's on here is the bigger number. It has a decimal on it. This is called the average atomic mass. It's an average because different elements of boron actually have different masses. Not every element of boron has the same mass. So we actually have to average them to get the average mass that's on the periodic table. Okay. This average mass, when we have it as a whole number, so in boron's case, because 10.81 is closest to the whole number 11, most boron has a mass of 11. So most boron has mass of 11, right? We just rounded 10.81 to the closest whole number. And this is called the mass number, which isn't the average. It's actually just saying, like, what is the mass of a particular atom in the sample? Most likely it's going to be 11. And the mass number comes from adding up the mass of the particles that are inside of the atom. Remember that atoms are made of 3 particles: protons, neutrons, and electrons. One of those particles doesn't have a mass. That's the electrons. They're so tiny that their mass is so small that we can essentially round it to 0. So the mass of the atom doesn't come from the electrons, it comes from the other 2 particles though, protons and neutrons. So just think of the mass number as being all the particles added up to get the mass, except electrons don't have a mass, so I don't have to add them into the mass. There's 2 other ways that we can write atomic names. And so I could write the full name boron and then write a dash and then write the mass. I never have to write the 5, which is the atomic number for boron, because boron always will have an atomic number of 5. It's kind of like saying boron. Oh, it's the element with 5 protons, right? If I told you the element with 5 protons, you know it's boron. If I tell you boron from the periodic table, you know it has 5 protons. The mass, however, can change because an average doesn't tell you about the specific atom. Most boron has a mass of 11, because that's closest to 10.8, but some boron has a mass of 10, right? Just like if your average GPA is, 3.2, that means most of your grades were Bs, but you probably have some A's in there and maybe a C or 2 as well mixed in. The other way we can write this is we can write the element symbol B for boron, and then in the top left corner, we could write the mass number. So this is 2 other ways that we could write the same symbol. A third way we could write this is boron with the mass of 11 in the top corner, and then down low we could write the number of protons to show that. That would go down low in our symbol. So this is actually a third way that we can write the element symbol. All right, let's go ahead and take a quick look at some problems. So if you flip over to the next page, which is page 4, if we wanted to look at some examples of some different elements and figure out how many protons, neutrons they had, when we look at this first example, we have 12, 6, C. Remember that that top number is the mass number. So in this case, 12 is our mass number. This is carbon with a mass of 12. The bottom number is the atomic number. And so for carbon, the atomic number is 6. And then from here, we could use this information to solve for protons and neutrons. We said that the number of protons is the same as the atomic number. So whatever the atomic number is the number of protons. So carbon has 6 protons. And then for neutrons, we said before that protons and neutrons are going to add up to the mass, because electrons essentially have no mass. So if I just add protons and neutrons, I get the mass. Mass should be equal to protons and neutrons added together. So if we look at this, 6 is what we have so far. We want to get to 12. So 6 plus 6 would equal 12. We could continue that with the next one as well. So 13, 6, C. 13 is our mass number. The number down low, the 6, is our atomic number. Notice that this is still carbon, so the atomic number did not change, but we're just saying, oh, it's a different form of carbon that's heavier. Some carbon was 12, and this one, some carbon is 13. From there, the number of protons is the atomic number, so that's going to be 6 still. And then to figure out the number of neutrons, we want to figure out, well, if the mass is 13, that's 6 plus, in this case, 7 to get us 13. We have 3 more like that on here that are the same format that you see on here. I'm going to skip down to one that's a little bit different. So if we look at Mg, this one doesn't have any numbers next to it, so we have to do a little bit more work, not a lot. We actually have to find it on the periodic table first so that we can get some information. So if I find Mg on the periodic table, I see the top number is 12. That's our atomic number. And then on the bottom, I see 24.31. That's our average atomic mass. So I'm going to fill in those two pieces of information. So the atomic number on the periodic table is always the one that's that whole number that's smaller, so 12. And then average atomic mass is the one that has the decimal, so 24.31. Okay, so those came from the periodic table. Excuse me. In order to solve the rest of the problem, I can't have a decimal because I can't have 0.31 of a neutron or a proton. So we need to do a little bit of work just to round this to the nearest whole number. So if magnesium has an average atomic mass of 24.31, well, what mass does most of it probably have most of the time? The closest whole number to 24.31 is 24. So this is us just rounding to the nearest whole number. From there, the rest of the problem is the same. The number of protons is the atomic number. The atomic number is 12. And then to get the number of neutrons, the mass comes from the protons and the neutrons added together. So 24 is equal to 12 plus 12 would get us 24. So the next two are just like that. Use your periodic table to find the numbers. If we skip down to this one, we see something that's a little bit different again, Ag-108. And what we said on the previous page is that when we have the symbol and then the -108, that -108 is our mass number. So I'm going to put that over here in our mass number box. Remember, if you're only given one number like that for the element, it's going to be the mass because I can always look up the atomic number on the periodic table. So if I look on the periodic table and I find Ag, its atomic number is 47. Okay, so again, I have to do a little bit of work to look up that number for atomic number, but the mass was given to us. Atomic number is the number of protons, 47. And then our mass comes from adding up the protons and the neutrons together. So I need to figure out what number, when added to 47, gets me 108. So you can use a calculator for this. I'm just going to think of the last digit, 7, to turn it into an 8. I would need to add 1. And then a 40 would need to turn into 100. So I would have to add 60 to turn 40 into 100. So 1 plus 7 is 8, and then 6 plus 4 gets me that 10. So 61 neutrons would be needed. Okay. You'll notice that these last three are also a little bit different. There's pluses and minuses. We haven't seen that yet. We're going to come back to this after we work a little bit more on the other side. All right, so back on page 3, what we just saw in a couple of examples was how to figure out the number of protons, neutrons, what the mass number is, and what the average atomic mass is. So we actually saw an example of an isotope. In our very first two rows, we had carbon with a mass of 12 and carbon with a mass of 13. In that case, we had the same element, which was carbon, and because it's the same element, it has the same number of protons. Carbon in those examples, the first two rows both had 6 protons. But what was different was the mass. We had carbon with a mass of 12 versus carbon with a mass of 13. The particle that changes to change the mass, if the mass is different, the number of protons is the same, the particle that changed was the number of neutrons. Carbon 13 had more neutrons than carbon 12. And we already looked at some examples like this too. So just as an example for chlorine, on the periodic table square for chlorine, the average atomic mass, just looking it up on my periodic table here, is 35.45. And so the average is 35.45, but that doesn't mean that any atoms of chlorine actually have that as their mass. Some chlorine has a mass of 35, Some chlorine has a mass of 37, right? And when I average these, it ends up coming out to be 35.45. If we think about that, 35.45, the closest whole number to that is 35. That tells us that more chlorine is this form of chlorine with a mass of 35. There's a lot less chlorine 37 in the world because the average is closer to 35 than it is to 37. All right. Our next piece on here is going to help us figure out the number of electrons that are in atoms, because we haven't done that yet on that chart on page 4. So electrons, just as a reminder, are negatively charged, and I'm going to abbreviate them a lot as an E-. These electrons are found outside of the nucleus, just moving around, and they're holding the space for the atom. So fan blades move around constantly. You wouldn't stick your hand into a moving fan because even though there's empty space between the blades, you know that those blades are coming and they're going to chop off your hand. And that's essentially what electrons are doing too. They move around constantly, they're holding that space for the atom. This is called the electron cloud. Okay, so not a lot of electrons, but they hold a big space for the atom. Okay. Because we know that electrons are negatively charged, and we know that protons are positively charged, the number of protons and number of electrons helps us figure out the charge of an atom. If we take the number of protons that the atom has, and we subtract the number of electrons, we subtract them because electrons are negative, that would tell us the charge. So let's just say that we had an example where we had something with 6 protons and 6 electrons. 6 positives and 6 negatives would give us a charge of 0 because it's the same number of positives and negatives. However, if we had something that had 9 protons and 10 electrons, if we look at this, there's more electrons. That tells me that the charge is going to be negatively charged because there's more electrons than protons. And then our next question would be, well, how many more electrons are there? The 9 protons get canceled out by 9 of the electrons, but there's still 1 extra electron left over. So if we look at our little equation over here, 9 minus 10 would have gotten us -1, which is how imbalanced the protons and electrons are, what the charge is. All right, a little bit more and then we'll do some practice. So an atom is a vocab word that means neutral overall. That means there's no charge. So if we say that something is an atom, that means 0 is the charge. So this happens anytime that the number of protons and electrons are equal. The other scenario that we already looked at up here with 9 and 10 is called an ion. Ion just means that I actually do have a charge. So we have an atom that started out as neutral and then it became charged. This happens when the number of protons and electrons are not equal. They're not the same. Okay. We already looked at one example up here. Let's look at one more example. Let's say that we have, let's look at 2 examples. We'll say we have lithium with a charge of +1. So for lithium +1, if we wanted to figure out the number of protons and electrons, the number of protons just comes from looking at the periodic table and finding its atomic number, which is 3. So that means that I have 3 positives at this point. And I want to figure out how many negatives I have so that my overall charge is +1. You can either use our equation, protons 3 minus what number would give me an answer of 1. So 3 minus something equals 1. You can also look at this and say, okay, my charge is positive, which means I have more protons than electrons, and the difference between those 2 numbers is a difference of 1. That tells me my number of electrons is either 2 or 4, but because the charge is positive, I should have more protons. So the number of electrons would be 2. 3 minus 2 is 1. If we look at one other example, let's say that we have oxygen with a charge of -2. From my periodic table, I'm going to find oxygen on here. Oxygen has 8 protons. And overall my charge should be -2. The 2 tells me that the number of electrons is different from the number of protons by 2, which means that my number of electrons is either 6 or 10, because those are the two answers that are 2 off from 8. And then when I look at the negative sign tells me that there's more negatives than positives. So if I'm thinking the answer is either 6 or 10, it should be 10, because there's more negatives than positive. That's why my answer is negative. Again, if you use our equation, number of protons minus electrons should equal -2. 8 minus 10 would give me -2. Last thing on here, the term isoelectric means that we have the same number of electrons. Electric means electrons, and iso means same. So if we look at this, what we just said here, 10 electrons for oxygen. I also did an example right up here that had 10 electrons. If I wanted to figure out which element this was, 9 protons, 10 electrons with a charge of -1, I just need to figure out what element number 9 is. Element number 9 is fluorine. So fluorine with a charge of -1 also has 10 electrons. Those two elements are isoelectric to each other, the same number of electrons. All right, let's take a look at one more example over here. So we'll look at 2. So the last column that we hadn't filled in was the number of electrons. So that's this column over here that up until now has been blank. If our element does not have a charge, which is the case for all of them except for the last 3, then the number of protons and the number of electrons are the same, because all of these ones in this whole first section do not have a charge overall. They're all atoms. Okay. Once we get to the last 3, however, the last 3 on here do have charges. We see that written in the top right corner, +2, +3, or -2. That tells us that the number of protons and electrons are not the same. If we look at iron, that's Fe, I'm going to find it on the periodic table. The atomic number is 26. The average atomic mass is 55.85. I need to round this to the nearest whole number, so 55.88 rounds up. So that would become 56. Our next column on here is protons, which is the same as the atomic number, which is 26. Our next column is the neutrons. The number of neutrons plus the number of protons should equal the mass. So 56 should be equal to 26 plus the number of neutrons. So in order to get from 26 to 56, I need to add 30. And then our last column is the number of electrons. And so when we look at this, I see that the charge is +2. That tells me that the number of protons and electrons are not equal. The fact that it's positive tells me that there's more protons than electrons. So the number of electrons is less than 26, and it's less than 26 by 2. So the number that's less than 26 by 2 is 24. You could also use our equation. 26 minus what number would get us 2, and that would be 24. Okay. I will make a key for this page so you can check the rest.